Pascal Math Contest 2000 Green 9. Number 1, the value of 5 squared plus 2 times 5 minus 2. 5 squared plus 2 times 5 minus 2. So by the math, we do bracket first. 5 squared plus 2 times 3. And 5 squared, that's the 25, plus 2 times 3, that's the 6. Therefore, that's the 31. That's the answer C. Number 2, the sum of 29 plus 12 plus 23. 29 plus 12 plus 23. So 12 plus 23, that's the 35. 35 plus 29, that's the 64. The answer in the exponent, 64, we know that's the 2 to power 6. Therefore, the answer is B. Number 3, if x equals 4, y equals negative 3, then the value of x minus 2y over x plus y is x minus 2y over x plus y. Plug in x equals 4. That's the 4. And y equals negative 3 times negative 3. X is the 4, y is the negative 3. The numerator, that's the 4, negative 2 times negative 3, that's the positive 6. Denominator is the 4 minus 3. Now, that's the 10 over 1, just 10. Therefore, the answer is E. Number 4, if the following sequence of 5 arrows repeats itself continuously, what arrow would be in the 48th? So that's the 1, 2, 3, 4, 5, the figure repeating. So they ask 48. Every 5 repeating, we use the 48 divided by 5. That's the 9, and the remainder 3. So remainder 1 is, that's the remainder 1. Remainder 2. Remainder 3 is the third figure. Remainder 4, that's the fourth figure. Remainder 0, that's the last figure. Remainder 1 is the first, remainder 2 second, remainder 3 third, remainder 4 fourth, remainder 0, that means divisible. That's the fifth figure. So 48th position, that's the remainder 3. The answer is C. Number 5, if y equals 6 plus 1 over 6 and 1 over y, so y equal to 6 plus 1 over 6. That means 6 and 1 over 6. Write as the improper fraction. That's the 6. 6 times 6 plus 1. That's how we write mixed to the improper. So that's the 37 over 6. Reciprocal of the y, 1 over y, just the flip numerator and the denominator. That's 6 over 37. Therefore, the answer is A. Number 6, if 2/3, 23 over 30, 9 over 10, 11 over 15, 5 over 4 are written from smallest to largest, then the middle fraction will be. So the 3, 30, 10, 15, 5 LCM, this the common multiple of these the 5 numbers is 30. Each fraction use the LCD rewrite. So 2 over 3 numerator denominator times 10. That's the 20 over 30. So the second 23 over 30 is already 30. 9 over 10, that's the numerator denominator times 3. That's the 27 over 30. And the 11 over 15, numerator denominator times 2. That's the 30, 22. The last one is the 4 over 5 times 6 over 6. That's the 24 over 30. Now the smallest one we compare is the 2 over 3. Second is the 22 over 30. That's the second smaller. And then 23 over 30, that's the third. After that, that's the fourth is the 24 over 30. Largest is the 27 over 30. So they ask, what's the middle fraction? Middle 5 number, middle fraction, that's the 3. So that's the 23 over 30. That's the answer A. Number 7. 3 squares with the same center and corresponding parallel sides are joined. The distance between the sides of the successive square is 3, and the side length of the largest square is 22 as shown. What is the perimeter of the smallest square? Now let's copy and enlarge this figure. So it shows that between the two, the square distance is the 3. Same thing, right side is also 3. Now we are looking for the perimeter of the smaller one, the size of smaller square. So the total length is the 22, and then minus this 2, 3. That's the minus 6. Also minus right side 2, 3. That's the 6. So it's the 10. That's the size of the smaller square. So they ask a perimeter. Perimeter equals the 4 times side length. So that's the 4 times 10. That's 40. Therefore, the answer is A. Number 8. In the diagram, the value of y is. Now I copy and enlarge the graph. So these two arrow line, that's these two the arrow sign. That means they are parallel. The parallel line, we use the arrow. These two arrows, that means this parallel. When they parallel, so x equals y. X and y we call the alternate interior angle. So for the parallel line, all alternate interior angles are equal. Now this one. So inside the triangle, we know 3 angles of triangle is 180. So 180 equals 60 plus y. 2x equals y, plug in, that's plus 2y. and 3y equals 120. Move the 60 to equation another side, that's negative 60. That's the 3y equals 120. Y equation both sides divided by 3. Y equal to the 40. Therefore, the answer is E. Number 9. The ages of 3 contestants in the Pascal contest are 14 years 9 months, 15 years 1 month, and 14 years 8 months. This average is average. We know that's the sum of number divided by the number of number. That's the average. So the average of this one is the 3 contestants. So that's the over 3. The numerator first one is the 14 years 9 months. We write as the months. So 14 times 12. That's the 168 plus the 9 months. That's the 177 months plus the 15 times the 12. That's the 180 plus 1 month, 181 plus 14 times the 12 plus the 8, that's the 176. And now we calculate the sum of the 177 plus 181 plus 176. That's the 534 over 3. That's divided by 3. That's the 178. 178, that's the months. We need to calculate the years because they gave the how many years, how many months. So the 178 divided by 12, that's the 14. We use that divided 12 times 1 over 12, give us the 14, and 5 over 6. That means the 14 years. 14 years. 5 over 6 years times 12. 1 year has 12 months. Cancel 6. That's the 10. That's the 10. So that's the months. So the average of the 3 contestants is the 14 years, 10 months. That's the answer C. Number 10. The number of integers between negative square root 8 and square root 32. They ask integers, so we find the squared number is the 1, 4, 9, 16, 25, and 36. So 36, square root 36, that's the, take the square root, that's the 6. So because they between negative 2, so it's the less than or equal to from the 5. The square root of 5, that's the 5. So that's the 5, 4, 3, 2, 1. After 1, because they ask integer, integer is the positive whole number, negative whole number, and 0. So still have the 0. And 8 is the between 4 and 9 for the negative. Negative the 1, so negative the 4 negative 9. Negative 9 is take the square root of the 9 is the negative square root 9. That's the negative 3. Negative 3 is less than negative 9. So from the negative 4, so 0, negative 1, negative 2, because the 4 square root, that's the 2. So add the negative sign, negative 2. So the total is 1, 2, 3, 4, 5, 6, 7, 8. That's the answer D. Number 11. A store had a sale on t-shirt. For every 2 t-shirts purchased at the regular price, a third t-shirt was bought for $1. 12 t-shirt was bought for $120. What was the regular price for t-shirt? So let X be the regular price. So that's the every 2 t-shirt. When we buy the 2X, that's the 2 t-shirts cost. Third t-shirt cost $1. So that's the total 3 t-shirt cost 2X plus 1. So total bought the 12 t-shirt, we times 12 divided by 3, because every 3 it's the set is the by 2, the 1 for $1. So that's the total 3. We use the 12 divided by 3. That's the total we bought. And then total cost, that's given 120. Now that's the 4 times 2x plus 1, 120. So expand, use the distributive property. 8x plus 4 equal to 120. Bring the 4 to equation another side, that's the negative. 120 minus 4 is the 116. So 8x equals 116. Equation both sides divided 8 to isolate x. X equals, so that's the 1 give us the 36. 4 times 8, 32. That's the 40.5. So original price of t-shirt is $14.5. That's the answer D. Number 12. In the diagram, every number beginning at 30 equals twice the sum of the 2 numbers 2 is immediately left. The value of C is, so from 30 equals the sum of the previous number times 2. So that's the A plus 10 times 2. Same thing, the B equals 2 times 30 plus A. C equals 2 times B plus 30, 30 plus B. From the first equation, so 30 equals 2A plus 20. That's the distributive property. Use the 2 times A, 2 times 10. That means the 2A equals 10. That's the A equals 5. A equals 5. The B equal to 2 times plug in A equals 5. 30 plus 5. That's the 35 times 2, 70. and C equal to 2 times 30 plus 70. 30 plus 70, that's the 100. 100 times 2, that's the 200. Therefore, the answer of 12 is E. Number 13, in the expression A over B plus C over D plus E over F, each letter is replaced by a different digit from 1, 2, 3, 4, 5, 6. What is the largest possible value of the expression? So the expression is the A over B plus the C over D plus E over F. We try to get the largest possible value. That means we use the larger numerator, use the smaller the denominator. The largest digit is the 6, so we put the 6, 5, and 4 as the numerator. Denominator, largest number, we put the smallest the digit will give us the largest one. And 5 over 2 plus 3 over 4. 6 over 1, that's the 6, and 5 over 2, 2 and 1 half, and 3 over 4, that's the 1 and 1/3, and the integer part is 6 plus 2 plus 1, that's the 9. 1 over 2 plus 1 over 3, that's the 5 over 6. So the answer is the B. Number 14. The number of 6, 14, x 17, 9, y 10 have a mean of 13. What is the value of x? The mean is the average. So the average always use the sum of number divided by number of number. So in this problem, sum of the number is the 6 plus the 14 plus x plus 17 plus 9 plus y plus 10 divided by 1, 2, 3, 4, 5, 6, 7 numbers. That's equal to 13. So add all them together. So that's the 20, 30, and 26. All together, that's the 56. So 56 plus x plus y. Equation both sides times 7. That's the 91. X plus y equal to, move the 56 to another side, also changing the number sign, minus 56. That's the 35. So the answer is E. Number 15, the digits 1, 1, 2, 2, 3, and 3 are arranged to form an odd 6-digit integer. The ones are separated by 1 digit, the 2's by 2 digits, and the 3's by 3 digits. What are the last 3 digits of this integer? So they form the 1, 2, 3, 4, 5, 6 digit. And also it's the odd digit. Odd digit, that means one's digit can only be 1 or 3. Now we try the 1. If I put the 1, so the 1 are separated by 1 digit, so we can put the 1 here. So between the 1, we can put 2 or 3, it doesn't matter. We put the 2, we will put this one 2. And the 3 must separate by 3 digits, so that not work. If I put the 3 here, and then 1, 2, 3, we put the 3 must be here, but we leave the 2 space, 2 digits for the 2, so it doesn't work for 1. Now we will look at if the 3 works. I put a 3 here. They must separate by 3 digits, so 3 will be here. And then in the middle, that's the 3 digit. Definitely we can put the 1, 1 at here. Now the missing the digit, we put the 2. The front digit, we put the 2. So we will check if it satisfies all the restriction. So the 1 separated by 1 digit, now it works. 2 separated by 2 digits, so 2, 2, they have the 1, 3, works. 3 separated by 3 digits, it works. 1, 2, 1. So that's the 2, 3, 1, 2, 1, 3 is such an odd number. The question is, what are the last 3 digits to this integer? The last 3 digits is the 213. That's the answer E. Number 16. The area of square ABCD is 64. The midpoints of its sides are joined to form the square EFGH. The midpoint of its side is the JKLM. The area of shaded region is. Let's join some segment. So we connect KB, AJ, and KL, JM. Connect this one all together. So now we get the sum, actually that's I got the exactly same the triangle. How many the triangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The 16, that's the total, the triangle. So the shaded part, that's the 1, 2, 3, 4, 5, 6. The fraction of shaded is the 6 over 16. What's the area? We use the shaded fraction times the total area. Total area given, that's the 64 times 64. So cancel 6, 16, that's the 1. Cancel 16, that's the 4. 4 times 6, 24. So the answer is B. Number 17. In the diagram, the value of the height is. Now let's label this side as the x. For the triangle area equals the 1/2 base times height. If we use the 25 as the base, that will be 1/2 25 times h. If we use the 20 as the base or x as the base, that will be 1/2 20 times x. So we simplify this the equation. So equation both sides, cancel 1/2. Then we cancel the 5. That will give us the 5h equals the 4x. So in h in terms of x, that means h equal to 4/5x. Now we find the x. We can use the Pythagorean theorem. That means the c squared equals a squared plus the b squared. So we also can use the Pythagorean triple. This is the 3, 4, 5 triple. 3, 4, 5 is the Pythagorean triple. 4 is the time when we times 5 each side. So that will be 15, 20, 25. So the x equals 15. So plug in x equals 15. 4/5 times 15. Cancel 5. That's 3. Therefore, the answer is 12. If you are not familiar with the Pythagorean triple, just use the Pythagorean theorem. That's the 25 squared equals 20 squared plus x squared. So that's another way to do this one. We can find the x. So therefore, the answer of 16, that's 12. That's the answer D. Number 18, in the diagram, the 5 smaller rectangles are identical in size and shape. The ratio of AB to BC is. Now, that's the smaller rectangle length. That's the x. And the width is the y. Now, the AB equals the x plus 2y. And also the BC, that's the x. So this is the y. The AB, the ratio AB to the BC equal to AB, that's the x plus the AB equals x plus the 2y, and x equals 3y, same thing. So 3y plus 2y, that's the 5y. So AB is the 5y. To the BC, that's the x. We already know x equals 3y. So x equals 3y, simplify. 5 to 3. So the answer is D. Number 19, the year 2000 is a leap year. The year 2100 is not a leap year. The following are the complete rules for determining a leap year. Rule 1. Year Y is not a leap year if Y is not divisible by 4. Rule 2. Year Y is a leap year if Y is divisible by 4, but not by 100. Rule 3. Year Y is not a leap year if Y is divisible by 100, but not divisible by 400. Rule 4. Year Y is a leap year if Y is divisible by 400. How many leap years will there be from the years 2000 to 3000 inclusive? Now we look at the first two rules. So we look at the two together. Year Y is a leap year if Y is divisible by 4 but not divisible by 100. Now first we find how many numbers from 2000 to the 3000 divisible by 4. Divisible by 4 rule, last two digit divisible by 4 or last two digit is 00. So 2000, 3000 both divisible by 4. So we use the number of the number formula. Arithmetic sequence, number of the number formula is the last number minus first number divided the common difference plus 1. So divisible by 4 from 2000, 2004, 2008, continue on 3000. This is the arithmetic sequence. So we use the formula 3000 minus 2000 divided by common difference 4 plus 1. That's the 251. 1000 divided by 4, that's the 250 plus 1. That's the 251. Now look at rule 3, rule 4. So Y is a leap year if Y is divisible by 400, but the divisible by 100, but not divisible by 4. So that's the 2 means the divisible by 100 is not leap year. But divisible by 100, also divisible by 400, that's the leap year. So first we find how many numbers divisible by 100. We still use the formula 3000 minus 2000 divided by the 100 because the divisible by 100. So 2000, 2100, 22, then plus 1. That's the 1000 divided by 1000, that 1000 divided by 100, that's the 10 plus 1, that's the 11. But in these 11 numbers, how many numbers divisible by 400? So now we need to find out how many numbers divisible by 100, but also divisible by 400. Divisible by 400, and that's the leap year. So from the 2000 divisible by 2, divisible by 400, and 24, 2800. That's just the 3 numbers. These 3 numbers are leap year because they divisible by 100, but also divisible by 400. Year 4 is leap year if it's divisible by 400. So the total number of 251 minus 11 plus 3. That's the 243. So the answer is C. Number 20. A straight line is drawn across an 8 by 8 chalkboard. What is the greatest number of 1 by 1 squares that which this line could pass? This is the 8 by 8 chalkboard. So they ask what is the greatest number of the square we can cross. Now usually we draw the diagonal. Look at this diagonal. It crosses 1, 2, 3, 4, 5, 6, 7, 8. It crosses the 8 square. But if we draw a line a little bit, move above. Now we draw another line. See if we can go across the more square. So we draw a line like this. Now how many square it cross? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the maximum the square the line can go through is the 15. That's the answer E. Number 21. ABCD is rectangle with AD equals 10. If the shaded area is 100, then the shortest distance between the semicircle is. Now the given AD equals the 10. That's the diameter. So the radius is the 5. Diameter divided by 2. Same thing. This radius is the 5. Let's we let the CD be X. Shaded area is 100. Shaded area usually equals the all area minus the white part. The all area ABCD rectangle area is the length times width, that's the 10x, minus the 2 semicircle area. We use the 2 times area is the pi r square. Pi r square, that's the 5 square. And then divided by 2. That's the 1 semicircle times 2. That's the 2 semicircle. 100 equals 10x minus 25 pi. 10x equal to 100 plus 25 pi. Equation both sides divided by 10. X equals to 10 plus 2.5 pi. Now x equals 10 plus 2.5 pi. And they ask the shortest distance between the 2 semicircles. The green part is the shortest distance. They equal to x minus 10. That's the green part. X, that's the 10 plus the 2.5 pi minus 10. Cancel 10. That's the 2.5 pi. That's the shortest distance between the 2 semicircles. So that's the answer A. Number 22. A wooden rectangular prism has dimension 4 by 5 by 6. This solid is painted green and then cut into 1 by 1 cubes. The ratio of the numbers of cubes with exactly the 2 green faces to the numbers of the cubes with 3 green faces is. Now this is the 4 by 5 by 6 rectangular prism painted to the green, and then cut to the 1 by 1 by 1 small cube. The question asks the ratio of the number of the cubes with exactly 2 green faces to the number of the cubes with 3 green faces. So 2 green face to the 3 green face. For the 3 green face, that's the easy. We can find all the corner one. All the corner has the 3 face. Another 3 is the inside. So the rectangular prism, the corner, that's the 8 corner. So 1, 2, 3, 4. Let's see this, the 1, 2, 3, 4. We cannot, 1, 2, 3, 4. Opposite, another 4. Total, that's the 8. 8 corners with the 3 green face. All the small cube with the 2 green faces, that's the on the edge, that's the small cube on the edge. For the length of the 6 on the edge, we already count the corner, that's the 3 face. So for this one will be the 1, 2, 3, 4. So that's the 4. And then that's the 4. We have the 1, 4. Another, this is the 4. This is the 4. And the opposite bottom still have the 4. So that's the 4 times 4. So on the side, the 1, 2, 3, 3 small cube has the faces painted to green. So still have the 1, 2, 3, 4. So plus the 3 times 4. And then the vertical edge only have this one, 1, 2, only have the 2 cubes painted for the 2 faces. So we have the vertical 4 edges, 2 times 4. So for the rectangular prism and the cube, they all has the 12 edges. So we have the 1, 2, 3, 4. That's the 12 edges. So they equal to 8. The numerator is the 36. So 36 to 8, we cancel 4. That's the 2, 9. The answer is A. Number 23. The leftmost digit of an integer of length 2000 digits is 3. In this integer, I need 2 consecutive digits. Here, I need 2 consecutive digits must be divisible by 17 or 23. The 20th digit must be either A or B. What is the value of the A plus B? So we have the 2000 digit. So 1, 2, 3. So we continue on to the all 2000 digit. And any consecutive 2 consecutive digits must be divisible by 17. So divisible by 17 number is the 17, 34, and 51, 68, 85, and that's it. Divisible by 23, that's the 23, 46, 69, 92. So that's all. The very beginning, that's the 3, and the last digit, A or B. So we will figure out what's the A, what's the B. Now the start by the 3, second digit, that's the 34. Only 34 divisible by 17. After the 4, that's the 46. 3, 4, 6. But after 6, we have the 68 and the 69, two number. So that's the case work. We do the case 1. That's the divisible by 68. So that's the for after 6. So we will figure out after the 6. After the 6, 68. After the 8, the only one we can put is the 5. After the 5, that's the only one. After 1, that's the 7. After 7, so they go nowhere. No more the consecutive number after 7 can divisible by 17 or 23. So the first number, the stop the 7. The case 2, that's the 3. So first the 3, 4, so 6. After the 6, we do the 9. We don't do the 8. 8 we already done. So we do the 9. After 9, the only one is the 2. After 2, that's the 23. 3, 4, 6, 9, 2. Now is the 3. That means another 3, 4, 6, 9, 2. Now we find that that's the repeating. 1, 2, 3, 4, 5 digit repeating. 2,000 digits divided by 5. That's because this divisible by 5. That means the last digit is the 2. So we already talked about before. Remainder 1 is the 3. That's the remainder 2. Remainder 3. Remainder 4. The last digit is remainder 0. That means divisible by 5. So now we find that the A is the 2. But they said that they told us the given is the last digit, either A or B. We will replace this 5 more. We use the case 1, 5 more digit. So 1, 2, 3, 4, 5. Now we use this 5 digit, replace the last 5 digits. So that's the 3, 4, 6, 8, 5. So the last digit can be the 5. So B can be equal to 5. The A plus B, that's the 2 plus 5, is 7. So the answer is B. Number 24. There are 7 points on a piece of paper. Exactly 4 of these points are on a straight line. No other line contains more than 2 of these points. 3 of these 7 points are selected to form the vertices of a triangle. How many triangles are possible? Let's draw a straight line. So we have the 4 point on this straight line. So that's the A and B, C, and D. And another 3, so that's the A, B, C, D, that's the E, F, G. That's the casework we form the triangle. First the case, we choose the 2 from the A, B, C, D. So 4 choose the 2. That's the how many way we can choose. And another E, F, G, 3 point, we choose 1. So that's our case 1. 4 choose 2. That's 4 times 3. over 2 factorial, that's the 2 times 1, times 3, choose the 1, has the 3 choice, cancel 2, that's the 18. Case 2, we from the EFG choose the 2, so 3 choose 2. Other 1 points from this the ABCD, so 4 choose 1, equal to 3 times 2 over 2 factorial times 4 choose 1, that's the 4. So cancel 2 equals 12. We still have the case 3. Case 3. Case 3, we don't choose the points from the ABCD. We just choose the EFG. So that's the 3 choose 3. That's the 1. So total how many triangle? That's the 18 plus 12 plus 1. That's 31. So the answer is D. Number 25. Triangle ABC is an isosceles triangle in which AB equals AC equals 10 and BC equals 12. The points SR are on BC such that BS to SR to RC equals 1, 2, 2, 2, 1. The midpoint of AB and AC are P and Q, respectively. Perpendiculars are drawn from P and R to SQ, meeting at M and N, respectively. The length of MN is. Now we label that some number. AB equals BC equals 10, that's the 10. And BC equals 12. BS to the SR to RC is the 1, 2, 2, 2, 1. So this is the 1, 2, 2, 2, 1. Total is the 4 part, so the BS is the 1/4 of the 12. That's the 3. And also RC is the 1/4 of the 12, still the 3. The middle part is the 2/4, that's the half of the 12, that's the 6. PQ is the midpoint. PQ is the midpoint. BP is the 5. AP 5, same thing. AQ 5, QC 5. When we connect the PQ, we call the midline. What's the midline? Midline is connect the two midpoint, not median. Median connect the one midpoint with the opposite vertex. Like if we connect the PC, that's the median. But when we connect the two midpoint, we call the midline. Midline theorem, that means the midline PQ parallel the base BC, also PQ equal to half of the BC. The BC is the 12, so PQ is the 6. So PQ parallel to the SR and they are the same length. So if we connect the PS, we connect the PR, that's the rectangle. Because they are the same and parallel, and they are the rectangle. So now we got the PQRS, that's the rectangle. So For the triangle BPS, that's the right triangle. PQRS is rectangle, so the base, the angle here, PSQ, that's the right triangle. So same thing, the right triangle. So that's the 3, 5. PQS right triangle. So that's the 3, 4, 5 Pythagorean triple. So that's the PS is the 4. PS is the 4. Use the Pythagorean theorem. PS square equals the 5 square minus 3 square. So still you get the 4. That's the PS. So now we look at another, the right triangle. That's the SPQ. So for the triangle SPQ, so SQ square equal to the 4 square, still Pythagorean theorem, plus the 6 square, that's the 16, plus 36, that's 52. So SQ equal to the square root 52. We don't need to simplify because we still need to use the Pythagorean theorem to find the Mn. So they ask Mn. Now we look at the PSM. PMS. Triangle PMS similar to triangle PSQ. That's the AA similarity. Which AA similarity? Angle PSM equal to the angle PSQ. They share the same angle and also another angle. Angle SPQ equal to the angle PQS. The angle SPQ equals PQS. Why? Because this the PSM 加上 PSM plus SPQ equals the 90 degree. Same thing, PSQ plus the PQS still equal to the 90 degree. PSM equals angle PSQ, so the angle SPQ equal to the angle SPQS. So actually, for the similar triangle in the right triangle, I need the right triangle like this. That's the right triangle. When we do the perpendicular line to here, so all these 3 right triangle, the triangle smaller 1, smaller 2, and the big the triangle, they all the similar. So all the AA similarity. So they are similar. So now we write the corresponding part are constant. So that's the SQ. So we use the SQ, that's the right triangle. The two triangles similar. So corresponding the sides are the corresponding sides ratio are constant. So 4 is the small triangle, the hypotenuse. big triangle SPQ, the SPQ, the side length SQ, that's the hypotenuse. Hypotenuse over hypotenuse, that's the root 52. And also, we try to find the SM. So, what's the SM? We don't know. We put the X, or we just put the SM. SM is the angle opposite to the SPM. Opposite to SPM. So SPM equal to the PQS. So opposite PQS, that's the PS, that's the 4. So SM cross multiplying SM times root 52 equal to 16. SM equal to 16 over root 12 over the root 52. 52 is the simplify the 52, that's the 4 times root 4 times 13. So we can factor out the 4. That's the 2, and the inside is the 13. We cancel 2, that's the 8. So 8 over 13, that's the SM. And the SM, look at this, the small to the right triangle, SPM and also SNQR. These two right of the triangle, they are congruent. The congruency is the angle, the congruency. So let's go a little bit over. So these two triangle, the triangle SPM is the congruent to the triangle NQR. The congruency is the SAS. S side length, that's the PQ equals the QR. So PQ equals the QR. The two triangles are congruent. Congruency is the SAA. So these two triangle is the ASA, the congruency. ASA. ASA, that's the angle side angle congruency. They have, because of the PQ, PS parallel to the QR. So these two angle. So let me use the different. These two green angle are equal. They are alternate interior angle. Alternate interior angles are equal. Another angle, that's this one. So let's use another one. Right angle, still the equal. Because the right angle plus the green angle equals 90. So green angle equal, yellow angle are also equal. And the two angle, between two angle is the 4. 4 equals the 4. So ASA. So yellow side and green. These two angles the congruent. So SM equal to NQ. Corresponding part equal. Corresponding part equal, that's the SM opposite to yellow angle equal to the NQ opposite to yellow angle. So they are the equal. Now the MN, finally we can find the MN. Let's come to here. MN equals SQ minus SM minus NQ. And SM and NQ are equal. SQ equal to SQ equal to root 52 minus SM equal to 8 over root 3. So 8 over root 13. SM equals 8 over root 13. 8 over square root 13. And we times 2 because NQ is the same thing. Now we simplify this one. Now the root 13 equal to root 13. That's times root the 52. Root 52, that's the 2 root 13 times root 13 minus 16. They equal to root 13. So that's the root 13 times root 13. That's the 13 times 2, 26. So 13 times 2 minus 16 equal to 10 over root 13. So that's the answer B. That's the root 10 over root 13. That's the answer B.